Good morning, students. Today I will discuss the subject Engineering Chemistry for all first year BE BTech program. I am Dr. M. Prabhakaran, Assistant Professor, Department of Chemistry, Erode Sengundar Engineering College. Unit 1 Water and its Treatment. So, in Unit 1 Water and its Treatment, what are the topics I will discuss? So, first one types of water. So water, there are two types, hard water and soft water, and then types of hardness, and then estimation of hardness by EDTA method, boiler troubles, internal conditioning, external conditioning methods, reverse osmosis, domestic water treatment. So first one, introduction. So water and its treatment. So first one, water technology. So water technology means process of removing all type of impurities from water, making it fit for domestic or industrial purpose is called as water treatment or water technology. So the main sources of water. So first one is rainwater is the purest form of water. Second one is surface water. So surface water means rivers and lake water. So third one is underground water. So well and spring water. Fourth one is sea water. Sea water is the unpurest form of water. So water is the most important component for our human beings, animals and plants. So main source of water, first one rainwater. Rainwater is the purest form of water. Second one is sea water. So sea water contain high salt content. So third one is surface water. So surface water, that means river and lake water, so containing high dissolved salts. Fourth one is underground water. So this one is crystal clear water, well and spring water. So water, there are two types of water. So first one is hard water, second one is soft water. So hard water means does not produce lather with soap solution. It produces white precipitate. White precipitate means scum. So white precipitate produced is called as hard water. So hard water contains dissolved salts, calcium and magnesium salts. So hard water means does not produce lather with soap solution. It produces white precipitate, presence of calcium and magnesium salts. So sodium soap is treated with hardness producing ion calcium, so to form calcium soap. So sodium soap is the water soluble, but calcium soap is water insoluble. So second one, soft water. So soft water means produce lather with soap solution, absence of calcium and magnesium salts. So hot water means does not produce lather with soap solution. Soft water means produce lather with soap solutions. Hard water, presence of calcium and magnesium salt. Soft water is absence of calcium and magnesium salts. So water, there are two types. First one is hard water, second one is soft water. So this image shows the first one, soft water. Second one image shows the hard water. So hard water does not produce lather with soap solution, it produces white precipitate, that means scum. So soft water produce lather with soap solutions, this means soft water. So there are two types of water, hard water and soft water. So second one topic, hardness of water. So hardness means one of the property of water. So water contains, there are several properties, pH, odor, taste, chloride, nitrate, sulfate and etc. So hardness is the one of the property or characteristics of water. So hardness means does not produce lather with soap solution. So that means hard water. So hardness is means hard water. So how to detect hardness? So first one is treated with soap solution to produce white precipitate, that means scum. So this water is contain hardness. So hardness, there are first one detection method, treated with soap solution, so to produce white precipitate. Second one is water is treated with eriochrome black tea, that means EBT. So water is treated with EBT indicator to produce wine red color. So that water contains hardness. So how to detect hardness? There are two methods. So first one, water is treated with soap solution to produce white precipitate. Second one is water is treated with eriochrome black tea indicator to produce wine red color. So there are two methods of hardness detection methods. So then types of hardness. So hardness, there are two types. First one is temporary hardness. Second one is permanent hardness. So types of hardness depend upon the types of dissolved salts present in water. So hardness, there are two types of hardness. First one is temporary hardness or carbonate hardness or alkaline hardness. So temporary hardness, another name carbonate hardness or alkaline hardness. So temporary hardness means presence of bicarbonates of calcium and magnesium. So temporary hardness or carbonate hardness or alkaline hardness. So presence of bicarbonates of calcium and magnesium. So bicarbonates formula, calcium bicarbonate and magnesium bicarbonate. So CaHCO3 twice, that means calcium bicarbonate. MgHCO3 twice, that means magnesium bicarbonates. The two salt present in water, so to give the temporary hardness, presence of calcium bicarbonate and magnesium bicarbonates. So temporary hardness, how to remove the temporary hardness in water? So normally in our house using the method boiling method. So first one method is removing of temporary hardness. First one is boiling the water. Second one is adding lime. So first one, boiling water. So calcium bicarbonate and magnesium bicarbonate. There are two salt present in the temporary hardness. So calcium bicarbonate gives the boiling the water. So to produce calcium carbonate, CaCO3, to form a precipitate, and then water, and then carbon dioxide, CO2. So second one, liming method, adding lime. So temporary hardness producing salt, magnesium bicarbonate, MgHCO3 twice. So lime formula is calcium hydroxide, CaOH twice, that means lime, calcium hydroxide. Magnesium bicarbonate treated with lime to produce magnesium hydroxide, and then calcium carbonate plus water molecule. So there are two methods removing for temporary hardness: boiling the water, adding lime. So second one, permanent hardness. So permanent hardness, another name non-carbonate hardness or non-alkaline hardness. So permanent hardness or non-carbonate hardness or non-alkaline hardness. So permanent hardness means presence of chlorides and sulfates of calcium and magnesium. So that means calcium chloride, magnesium chloride, CaCl2 calcium chloride, MgCl2 magnesium chloride. And then sulfate. So calcium sulfate means CaSO4, magnesium sulfate means MgSO4. So there are four salts, presence of chlorides and sulfates of calcium and magnesium. So calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. So these four salts due to permanent hardness. So how to remove the permanent hardness? So removing process, there are two methods. First one, lime soda process. Second one, zeolite process. Permanent hardness means there are 4 salt: calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. So first one is removal process, lime soda process, and then second one is zeolite process. So lime soda formula: sodium carbonate, CaCO, Na2CO3, sodium carbonate. That means lime soda treated with calcium chloride. So calcium chloride is due to permanent hardness salt. So calcium chloride plus sodium carbonate to form calcium carbonate precipitate, and then sodium chloride. Second one, zeolite process. So zeolite process, zeolite formula Na2Ze, sodium zeolite. So calcium sulfate is due to permanent hardness salt. So is treated with sodium zeolite, Na2Ze. So calcium sulfate plus sodium zeolite to form calcium zeolite, and then sodium sulfate. So there are two methods removal for permanent hardness. First one is lime soda process, second one is zeolite process. So lime soda treated with calcium chloride to form calcium carbonate, sodium zeolite treated with calcium sulfate to form calcium zeolite. So there are two types of hardness. First one is temporary hardness, second one is permanent hardness. So how to calculate total hardness? So total hardness is equal to temporary hardness plus permanent hardness. So hardness, there are two types of hardness: temporary hardness and then permanent hardness. So total hardness is equal to temporary hardness plus permanent hardness. So next one, unit of hardness. So how to measure the units of hardness? So there are 4 units. First one is ppm. ppm means parts per million. So the number of parts of calcium carbonate equivalent hardness per 10 power 6 parts of water. Second one is milligram per liter. 1 milligram of calcium carbonate equivalent hardness per 1 liter of water. Third one is Clark's degree. So the number of parts of calcium carbonate equivalent hardness per 70,000 parts of water. Fourth one is French degree. So the number of parts of calcium carbonate equivalent hardness per 10 power 5 parts of water. So there are 4 units. First one is ppm, second one is milligram per liter, third one is Clark's degree, fourth one is French degree. So ppm, parts per million, milligram per liter, and then Clark's degree simple degree CL, and then French degree simple degree FR. So relationship between various units. So 1 ppm is equal to 1 milligram per liter is equal to 0.1 degree, 1 French degree, and then 0.07 Clark's degree. So there are 4 units of hardness. So next one topic, estimation of hardness by EDTA method. So how to estimate the hardness by EDTA method? So EDTA means ethylene diamine tetraacetic acid. So EDTA is full form ethylene diamine tetraacetic acid. So this is section of EDTA. So in the center 2 CH2 molecule, and then left side 2 COOH molecule, and then right side 2 COOH molecule. So 4 acid, so that means tetraacetic acid, and then diethylene. So ethylene diamine tetraacetic acid, section of EDTA. So principle. So estimation of hardness by EDTA method. So this one is titration method. So first one is principle. So principle means hardness producing salt estimated by water sample against EDTA using EBT indicator at pH 8 to 10. So amount of hardness producing salt means calcium and magnesium ions estimated by EDTA using EBT indicator. So then second one is buffer solution is added. So buffer solution, what is the purpose means maintain the pH. So buffer solution, ammonium chloride, ammonium hydroxide mixture. That one is ammonia buffer, ammonium chloride and then ammonium hydroxide mixture is ammonia buffer. So to maintain the pH. EBT indicator is added to water sample to form wine red color B complex. So hardness producing ions, calcium and magnesium ions in present in the water sample. So he is stated with is adding EBT indicator. EBT full form eriochrome black tea. So to form a wine red color B complex. So V complex is again titrated with EDTA solution in the burette. So to form stable complex calcium magnesium EDTA stable complex. So this is one is principle of estimation of hardness by EDTA method. So second one is first one principle, second one is preparation of solutions. First one is EDTA solution, second one is standard hot water, third one is EBT indicator, fourth one is buffer solution. So first one EDTA, 4 gram of EDTA in 1000 ml of distilled water. So 4 gram weighed in a balance and then dissolved in 1 liter of distilled water. Second one is standard hot water. So standard hot water means 1 ml of standard hot water is equal to 1 milligram of calcium carbonate. So 1 gram weighed in calcium carbonate is dissolved in hydrochloric acid and then made up to 1 liter of distilled water. So second one is standard hot water. 1 ml of standard hot water is equal to 1 milligram of calcium carbonate. Third one is EBT indicator. So EBT indicator how to prepare? So 0.5 gram of EBT is dissolved in 1000 ml of alcohol. So 0.5 gram weighed in EBT indicator is dissolved in 100 ml of alcohol. So fourth one is buffer solution. So 67.5 gram of ammonium chloride and 570 ml of ammonia are dissolved and the solution is made up to 1 liter of distilled water. So 67.5 gram of ammonium chloride and then mixed with 550 ml of ammonia and then made up to 1 liter of distilled water. So there are 4 solutions is needed for this titration. So first one is EDTA solution, second one is standard hot water, third one is EBT indicator, fourth one is buffer solution. So there are 3 titration process. So first one, standardization of EDTA. So 20 ml of standard hot water is peppered out into clean conical flask and then add 5 ml of buffer solution and 2 to 3 drops of EBT indicator and titrated is against EDTA solution taken in the burette. So the end point is wine red color changes to steel blue color. So that noted the volume of EDTA solution is noted V1 ml. So first one, standardization of EDTA. So first titration, 20 ml of standard hot water is peppered out into 100 ml conical flask and then add 5 ml of ammonia buffer solution and then 2 to 3 drops of EBT indicator and then titrated against EDTA solution. So the endpoint color changes from wine red color changes to steel blue. So the volume of EDTA is noted V1 ml. So already prepare the standard solution. 1 ml of standard hot water is equal to 1 milligram of calcium carbonate. So 1 ml is equal to 1 milligram of calcium carbonate. So 20 ml of standard hot water equal to 20 milligram of calcium carbonate. So 20 ml of standard hot water consume V1 ml of EDTA. So V1 ml of EDTA is equal to 20 milligram of calcium carbonate. So that means 1 ml of EDTA consume 20 divided by V1. So this is calculation part. 1 ml is equal to 1 milligram. So that means 20 ml standard hot water is equal to 20 milligram. So 20 ml standard hot water consume V1 ml of EDTA. So V1 ml means 20 divided by V1. So second one, estimation of total hardness. So 20 ml of given hot water sample is prepared out into clean conical flask, and then add 5 ml of ammonia buffer solution and then 2 to 3 drops of EBT indicator and titrate against EDTA. So second one, calculation part, 20 ml of sample water consume V2 ml of EDTA. So 1 ml of EDTA is equal to 20 divided by V1. So that means V2 into 1 ml. So 20 ml of sampled hot water consume V2 into 1 ml. So 1 ml of EDTA is already known, 20 divided by V1. So 20 divided by V1. So 1000 ml of water sample means V2 into 20 divided by V1 into 1000 divided by 20. So 20 cancel and then 1000 cancel. So total hardness is equal to 1000 into V2 divided by V1 milligram per liter or ppm. So total hardness is the formula 1000 into V2 divided by V1 unit milligram per liter or ppm. So third one, estimation of permanent hardness of water sample. So this is third titration. 100 ml of sample water is taken in the 250 ml beaker, boiled for 15 minutes. So temporary hardness gets removed. Cool and filter the solution and make up to 100 ml in a standard flask by adding distilled water. So first 100 ml of sample water is taken in the 250 ml beaker and then boiled for 15 minutes. So temporary hardness gets removed. So then cool and filter the solution and add up to 100 ml standard measuring flask by adding distilled water. So 20 ml of given hot water sample into conical flask and then 5 ml of buffer solution added and then 2 to 3 drops of EBT indicator is titrated against EDTA solution. So third one, calculation part, 20 ml of sample hot water after boiling, filtering consumes V3 ml of EDTA. So V3 into 1 ml of EDTA means 20 divided by V1. So that means V3 into 20 divided by V1. So 1000 ml means V3 into 20 divided by V1 into 1000 divided by 20. So 20 cancel, 1000 cancel. So permanent hardness is equal to 1000 into V3 divided by V1. So first one, standardization of EDTA. Second one, estimation of total hardness. Third one, permanent hardness. So last one, how to calculate the temporary hardness. So already known in the previous topic, temporary hardness, total hardness is equal to temporary hardness plus permanent hardness. So temporary hardness formula, total hardness minus permanent hardness. So total hardness 1000 into V2 by V1 minus 1000 V3 by V1 is the permanent hardness. So is the common one 1000 divided by V1. So V2 minus V3. So temporary hardness is equal to 1000 divided by V1 into V2 minus V3 unit ppm. So estimation of hardness by DTM method. So first one is principle. So then preparation of solution, there are 4 solutions: EDTA solution, standard hot water, EBT indicator, buffer solution, and then 3 titration process. First one, standardization of EDTA. Second one, estimation of total hardness. Third one, estimation of permanent hardness, and then final one, temporary hardness. So first one, standardization of EDTA, 1 ml of EDTA equal to 20 divided by V1. Second one, estimation of total hardness, so is equal to 1000 into V2 by V1. Third one, estimation of permanent hardness, so permanent hardness is equal to 1000 into V3 by V1. So temporary hardness, total minus permanent, so 1000 divided by V1 into V2 minus V3 ppm. then next topic, boiler feed water. So what is boiler water? So the water is fed into the boiler for the production of steam is called as boiler feed water. The water is fed into the boiler for the production of steam is called as boiler feed water. So boiler feed water is completely free from turbidity, oil, dissolved gases, alkali, hardness causing substance. Hardness causing substance means hardness producing salt, calcium and magnesium ions. So boiler feed water is completely free from oil, turbidity, dissolved gases, alkali, hardness causing substance. So hot water obtained from natural sources is fed directly into the boilers. Some troubles or arises. So the troubles means boiler troubles. So boiler troubles means hot water obtained from the natural sources is fed directly into the boiler. Some troubles or arises. This troubles is known as boiler troubles. So boiler troubles are disadvantages of using hot water in boilers. So there are 4 troubles. So first one, scale and sludge. Second one, priming and foaming. Third one, caustic embeddlement. Fourth one, boiler corrosion. So there are 4 boiler troubles. So boiler troubles means water is fed directly into the boiler. Some troubles or arises. That means boiler troubles. First one, scale and sludge. Second one, priming and foaming. Third one, caustic embeddlement. Fourth one, boiler corrosion. So first one, scale and sludge. So scale and sludge means formation of deposit in boilers. So that means scale and sludge. So water is continuously converted into steam in boilers. The concentration of dissolved salts in water increases progressively. So scale and the sludge. So this figure shows the first one, sludge in boiler, second one, scale in boiler. So sludge means loose precipitate formation. Scale means hard adherent coating on the inner wall of the boiler. So this figure, first one shows sludge, second one shows scale. So first one, sludge. So if the precipitate is loose or semi-precipitate is called as sludge. So sludge are formed by the substance magnesium chloride, magnesium carbonate, magnesium sulfate, calcium chloride. So sludge means loose and semi-precipitate is called as sludge. So sludge are formed by the substance magnesium chloride, magnesium carbonate, magnesium sulfate and then calcium chloride. Second one is scale. So if the precipitate form hard and adherent coating on the inner wall of the boiler, that means scale. So hard adherent coating on the inner wall of the boiler is means scale formation. So scale are formed by the substance calcium bicarbonate, CaHCO3 twice, and then calcium sulfate and then magnesium hydroxide. So sludge there are formed by substance 4 salts, magnesium chloride, magnesium carbonate, magnesium sulfate and then calcium chloride. Scale are formed by substance there are 3 salts, calcium bicarbonate, calcium sulfate and then magnesium hydroxide. So comparison of scale and sludge. So sludge loose and semi-precipitate, scale hard adherent coating on the inner wall of the boiler. So forming substance magnesium carbonate, magnesium chloride, magnesium sulfate, calcium chloride are formed by sludge. So scale forming substance calcium bicarbonate, calcium sulfate and then magnesium hydroxide. So disadvantages, sludges are poor conductors, scale or thermal insulators. So there are both decrease the efficiency of the boiler. Sludge prevention methods. So sludge formation can be prevented by using soft water and then second one blow down operation. So there are 2 removal methods for sludge. First one using soft water, second one blow down operation. So blow down operation is a process of removing a portion of concentrated water by fresh water frequently from the boiler during steam production. So scale prevention methods. First one using acids, hydrochloric acid and then sulfuric acid. Second one method, external treatment method and then internal treatment method. Third one, scale can also removed by applying thermal shocks, scrapers, airbus, etc. So prevention method, there are two prevention method for sludge. First one using soft water, second one blow down operation. So sludge, there are three methods. First one using dissolving acids, second one external and internal treatment, third one applying thermal shocks, scraper and then wire brush. So requirements of boiler feed water. So boiler feed water must have the following requirements: hardness less than 0.2 ppm, soda alkalinity 0.15 to 1.0 ppm, caustic alkalinity 0.15 to 0.45 ppm, excess soda ash 0.3 to 0.55 ppm. So dissolved gases means oxygen and then carbon dioxide. So dissolved gases 0 ppm. So these are requirements of boiler feed water. So the boiler feed water, there are following requirements: hardness, soda alkalinity, caustic alkalinity, excess soda ash and then dissolved gases. So then specification and disadvantages. So already discussed, boiler feed water should be completely free from oil, turbidity and then suspended impurities, dissolved salts, dissolved solids. So and then disadvantages: decreasing thermal efficiency of boiler and then poor conductors. So then second one, framing and foaming. So framing is the process of production of wet steam. So priming is the reason: high steam velocity, very high water level, sudden boiling of water, very poor boiler design. So how to prevent the priming in boiler? So controlling velocity of steam and then keeping the water level lower using treated water, good boiler design. So this one, priming. So priming means production of wet steam. So causes and then prevention methods: high steam velocity, very high water level, sudden boiling, very poor boiler design. These are causes of priming. So then prevention methods: controlling velocity, keeping water level, treated water and then boiler design. So second one is foaming. So foaming means formation of stable bubbles above the surface of water is called as foaming. So foaming is caused by the presence of oil, gases, finely divided particles. So foaming prevention methods. First one is adding coagulants. So coagulants like that: sodium aluminate and then aluminum hydroxide. Second one, adding antifoaming agent. Antifoaming agent means synthetic polyamides. So framing and foaming. First one framing, second one foaming. Framing, production of wet steam and then causes prevention. Second one is foaming, formation of stable bubbles above the surface of water, causes and then prevention methods. So prevention, first one is adding anticoagulants, second one is adding antifoaming agents. So next one, caustic embrittlement. So caustic embrittlement means intercrystalline cracking of boiler metal. So intercrystalline cracking of boiler metal. So boiler water usually contains small portion of sodium carbonate salt present in the boiler water. So in high pressure boilers, the sodium carbonate decomposes to sodium hydroxide. So sodium carbonate present in the boiler water, so plus H2O, so to form sodium hydroxide. So sodium hydroxide flow into the means of air cracks and crevices present in the boiler. So iron plus sodium hydroxide, so to form sodium ferroate, Na2FeO2. So iron treated with sodium hydroxide to form a sodium ferroate, Na2FeO2. So causes, what are the causes for caustic embrittlement? So brittlement of boiler parts, particularly stressed parts like bend, joint, rivets. So these are stressed parts. So next one, prevention. Gastric embezzlement can be prevented by using sodium phosphate as softening agent instead of sodium carbonate. Second one is adding tannin, lignin. So first one, instead of sodium carbonate using sodium phosphate. Second one, adding tannin, lignin. So boiler troubles. So boiler troubles means boiler water directly obtained from the natural sources is fed directly into the boiler. Some troubles are arises. So the troubles means boiler troubles, scale and sludge, priming and foaming, and then gastric embezzlement. So next one, softening or conditioning methods. Softening or conditioning methods. So water used for the industrial purpose, free from hardness producing substance. So suspended impurities, dissolved gases. So water used for industrial purpose, free from hardness producing substance, calcium and magnesium ions, suspended impurities, and then dissolved gases, O2, CO2. So hardness producing salt from water is known as softening or conditioning of water. So process of removing hardness producing salt, calcium and magnesium salt from water, so is known as softening method or conditioning methods. So there are two softening methods, external conditioning and then internal conditioning. So softening, there are two methods, external conditioning method and internal conditioning methods. So next class I will discuss the detail for softening methods. Thank you.